Hello, good morning, good afternoon, good evening, wherever you're hailing from. Welcome to a very special episode of OpenShift TV. Today we're joined by the one and only Christian Posta, who happens to be a former Red Hatter. So he's one of our, brilliant minds that escaped us kind of thing that I feel like. And Christian is someone that knows an enormous amount about service meshes and just Kubernetes in general and how to build on top of Kubernetes in an effective and secure way. So having Christian on is a great honor to me because I look up to Christian and his writings all the time when it comes to stuff like this. So thank you for joining us today, Christian, and please introduce yourself to the audience. Sorry, you have to follow that.
Thank you for those kind words. Yeah, and thanks for having me on this program.
Yeah,
definitely excited to chat with you. And
yeah, let folks know where you're at right now and what you're doing these days.
Yeah, so my name is Christian Posta. I live in Phoenix, Arizona, where it's still pretty hot, in the hundreds.
Yeah.
I work for a company called Solo.io, and we are a startup focused around Envoy proxy, around service mesh technology, and operating service meshes in real enterprise environments, which is very tricky. And actually, we publicly announced that Solo raised their Series B round.
Oh, congratulations.
Today. Yeah.
Nice. Yeah. Congratulations indeed. Wow, that's a Series B. That's quite the feat, man. That's awesome.
That's one of the hardest rounds. And yeah, no, we're doing really well. We're growing the company, hiring like crazy, and yeah, things are going well.
That's awesome. That's great to hear. So I kind of just laid out a series of questions for us to kind of discuss, and I want, audience engagement because I feel like, to me, and this kind of touches on my first question, service meshes, why are there so many of them? Like there's this overabundance of them, and I kind of feel confused a little bit at this point, right? Like, yes, as someone that's like, I'm going to need a service mesh at some point, what should I reach for, kind of thing, right?
Yeah, and there's a lot of them because people won't stop building them.
Right.
Every week, every month.
Yes.
New handful. And there's a lot of confusion in the market. There's a lot of overlap. What are the why? So to your question, why are there so many?
Right.
People have different opinions of what the networking abstractions and APIs should look like. What's quite interesting, however, is that although there's a large number of service meshes and more seemingly to be announced, a majority of them are picking a single data plane technology. They're picking Envoy proxy.
Right.
And so then what is the difference between the different meshes? Well, it's the assumptions that were built into it. It's the APIs that were built into it. There is the user experience, the manageability of it, and so on. So that's where those are the axes that they're trying to differentiate on. But just like there was in the container ecosystem a few years back, there's different opinions about
different styles, different ways of doing things. Yeah.
So we're seeing that play out right now.
Right, but they're all based on Envoy, and it feels like a large majority of them. Yeah, not all of them for sure. Why is Envoy underneath the hood of so many of them, in your opinion? What makes that community so strong, or what makes that project so strong that for everybody from Google to Microsoft is, grabbing Envoy and doing something with it and making a service mesh out of it?
That's right. I would say similar to the way containers, Google did a lot of work in the container world, C groups and in Linux and so on. And they had their own thing internally. And then at some point, they published a bunch of papers about what they're doing, but then they finally said, all right, we're going to jump in and we're going to build it the way we would build it if we were doing it again. And I think for them, it would have been the third iteration for them building this type of infrastructure for Kubernetes. Well, they have something similar internally that resembles a service mesh.
Right.
And so they, started looking at, what is the next thing that complements Kubernetes when you start to build out these cloud platforms. And they were looking for something that resembled or something that fit the way they would build this next generation networking infrastructure. And they stumbled upon Envoy proxy pretty early. Now, combine that with the open sourcing of Envoy and the reasons why Matt Klein and Lyft built Envoy, they're very, very similar reasons. And the reasons, and Google did it and Lyft did it, everyone did it. Everyone tried to build this application layer networking using various tools, different proxies, and so on. But so I would say that, for all these different reasons, Envoy got open source, Google jumped in. You also saw people like Apple and eBay and Verizon, and a lot of people jumped in and said, oh, this looks like the thing.
Yeah.
And so that's what happened. And now, since then, and I'll fast forward, a lot of investment, a lot of work from all these various companies has gone into Envoy. Envoy is so first of all, it's at the CNCF. It's
been donated to CNCF. It's graduated, I think, right?
Oh yeah, it was one of the very first few graduated projects. It was Kubernetes, and Envoy, and there was one other one. Maybe it was
etcd. Core DNS.
I thought it was.
It was one of the early ones,
but I can't remember.
It might have been Prometheus. You're right. Yeah.
There was just a small subset of graduated projects, but so a lot of effort, a lot of work went into it. It's open source. It's CNCF. The APIs for extending it were very well thought out. And maybe that's a common theme with some of these technologies that have kind of crossed that chasm, I guess. Like Kubernetes also had this idea of building a very extensible API, so you can extend onto it and so on. That led a lot to its uptake and so on. Envoy, same thing. Right. And so a lot of work has gone into Envoy over the last few years now to make it the de facto proxy that you would use to build a service mesh.
And you've been doing a lot of that work too, right? Like you've been contributing upstream at Solo quite a bit, I understand.
That's right. That's right. Yeah. And so at Solo, actually, it's interesting. When Solo got started in 2017,
way back when.
Way back when, yeah. I joined the very beginning of 2019. So it was around for about a year or so, year and a half before I joined. But Solo was interested in how can we solve the enterprise challenges around functions as a service and serverless? And so, Idit and the team started digging around. They realized it's too premature for that.
Right.
So then the next thing was, all right, well, let's focus on applications in enterprise today and how we can modernize them and so on. And then service mesh came in to, they started looking at, I think it was probably around late 2017, 2018, maybe.
Yeah, that sounds about right.
Again, the service mesh ecosystem was still nascent and very new, and Istio was around, but it was kind of overhyped and wasn't there.
Yeah.
So the next step, she thought, well, service mesh is not ready yet. It will eventually, but what's the next thing? Oh, Envoy, and at least starting to get traffic into your clusters, into your OpenShift cluster, into your Kubernetes cluster, into your AWS investment, and so on. And so that we started with a single Envoy proxy deployment called we call it Glue, which is a gateway that allows you to kind of at the network level bring all these different applications together. And then I started to build from there, right? So we built on Envoy, and this is the same approach that we recommend people to adopt this type of technology. Start small, get value out of it. Envoy can provide a lot of value, and then grow into these super scaled out deployments where you have an Envoy with each single application instance managing all of your applications and so on. But that's a 201 or 301 level course. Not just
Right.
start at the beginning and work your way into it, just like you did with Kubernetes, right? So that's what we ended up doing, and now the rest of the service mesh ecosystem has sprung up and is continuing to evolve.
Yeah, and it's just it. So, in a nutshell, in your opinion, what is minimum viable service mesh? Right? Like, I feel like that is a question that people often like don't understand sometimes. Right? Like, what a service mesh actually does for them.
Yeah, I would say, I have my own thoughts about that.
Like, and that's
but
what I'd like to
I can
hear.
also share what the reality is of people adopting it and what they consider in their practical terms, their environments with their constraints and so on. What is the reason why you might go to a service mesh and how to start off adopting it.
Mm-hmm.
And without my own biases from Solo, you see the same pattern that I just described. That if you want to start with, for example, Istio, 95% of the time people start with the ingress gateway from Istio.
Yeah.
And getting traffic into their clusters, which makes sense. Mm-hmm. It's an understood pattern.
Yeah.
Right. And then from there, what they go to is, well, security ends up being one of the number one concerns. So they want traffic between their services to be encrypted.
Right. Because it could be traversing data centers, who knows, right. Maybe international boundaries, who knows, right. It needs to be encrypted regardless. Right.
Right. Exactly. So that's one of the first use cases that folks gravitate toward is just getting encryption between their services. Because up until then, it's been such a pain in the
a royal pain in the ass. But yeah, go ahead.
It's something that people didn't do and didn't want to do, because
putting TLS between their services was something Google pioneered, right? Like, why would you need to encrypt inside your network, right? Exactly. Like, the military had been doing it for years, but it was never considered like a normal thing in the private sector, which I thought was very unusual coming out of the military experience into the private sector. It's like, why aren't we just using HTTPS everywhere, right?
Right. Right. And one of the reasons is just too big of a pain in the ass to do it and to manage it and to keep it going.
Right.
So,
how does Envoy solve that problem, right?
Yeah. So in the case of a service mesh where you have these proxies, so I guess back up for a second, like in a service mesh, what we're saying is, instead of having all these centralized proxies somewhere at the edge or in the middle of an architecture, why don't we create a proxy suitable enough to be small and compact and lightweight and performant enough to live with the application. Right. So every application instance gets its own proxy. Nice. So there's no centralized bottlenecks or route, forced black boxes that everything has.
Someone changed a line of code and all of a sudden you lose everything in a cluster kind of thing.
Right.
Yeah.
Right. So now we've decentralized and put these proxies with each application instance. So each JVM has its own proxy. Each Node.js process has its own proxy. And then when the applications talk, they talk through their proxy.
Right.
Right. And so now between applications, if the traffic's going through the proxy that where the traffic's originating, that service, and it's going to another application which also has its proxy, and then there's some interesting behaviors that you can do between those two services, and one of those is encrypting the traffic. So the some of your audience is Java developers or Python or Node.js or whatever, but I came from a Java background, and configuring trust stores and key stores and all of that stuff.
I've administered Java servers for 10 years, and that's a nightmare, right?
It's a nightmare.
Getting all that working together and like a plane of Java servers is a nightmare. Yeah,
exactly. So now, instead of doing that, what we can from the service mesh perspective is say, hey, let's give Envoy these certs, and let Envoy, which is already in the request path and from the origin to the termination side of the communication transport, encrypt it there, right? Encrypt it before it leaves the application, and decrypt it when it gets to the application, and nowhere in between, obviously. So a direct end-to-end encrypted channel. And moreover, if you put the right certs and the right keys on both sides, you can get mutual TLS and
Right.
encryption and verification of identity on both sides. And the
Sorry for
application
my
doesn't
dog
have
in the
to know.
background.
No, that's fine. And the application doesn't care or doesn't know.
Right, like you
about
get an authenticated kind of trust almost
Yeah.
between the two services now, or
That's
between
right.
the two pods essentially talking to each other through the cluster network, so
Yeah.
forth, so on. So there's some questions about visibility and observability into what is actually going on inside that service mesh, right? Like our admin folks are like, that's great, I'm going to hand off TLS to a service, but I need to know how it works, right? Like, can you explain that process a little bit?
Yeah. So in that model, when I hinted at, well, we just give the certs out to Envoy, right?
Right.
There's a level of the control plane part of the service mesh. So we talked about how the data plane, or the proxies that go live with the application, they're in the data plane. They're handling the requests and the messages and so on. But there's still a component to service mesh that needs to operate and configure these different proxies, right? Doing that by hand is out of the question. So there's so for example, Istio or AWS App Mesh or any of the service meshes follow this pattern, where you have the proxies deployed with the application, and then a control plane to be able to drive the configuration. And in the MTLS model, or in the encryption model, what happens is the proxies come up, they say, hey, I'm service XYZ, and then they announce that to the control plane, and the control plane has to validate and verify that, okay, that this is actually service XYZ. And then what it does is it gives that service a certificate that has been signed by a trusted root. Okay. A certificate that says, yes, you are indeed XYZ. And so now service XYZ, service ABC, they have certificates, X519 certificates, that have been validated and trusted by a trusted third party. And now when they create the connection to each other, they present these certificates. And as part of managing certificates and that kind of stuff, there's also the expectation of expiration and rotation. And so the service mesh control plane manages that, right? So it rotates the certs and before they expire and so on. So now if XYZ and ABC have their own certificates, when they establish TLS, they share it, and they establish a mutual TLS connection there. And now service XYZ knows it's talking with service ABC, for example.
It's validated, it's trusted, it's like almost certified to a point that it's like, this is the thing that it's supposed to be talking to.
Yeah.
What are the possibilities of somehow injecting code, like vulnerability type things happening in that process, right? Like, how locked down is that process?
So
sorry, before I say that, to be graduated from CNCF, you have to pass a security, third-party security assessment. Yeah. Obviously, Envoy did that years ago and is continuing to meet that compliance from CNCF as far as that perspective goes. So I'm asking like this hypothetical question from an admin's perspective, like, could something go wrong in that process? Could somebody do something in that process to like fake me out and have me dumping creds? Yeah.
I mean, we're talking about security. So,
right.
Any sane security professional is going to say, yeah, of course, it can go wrong.
Yeah. So the thing is, though, that this is automated, right? Like,
so that's the thing, right? So what you could end up in a situation where one end gets compromised, right? So for other reasons, maybe your pod, your cluster has some vulnerability, and you can get access to the pods and somehow take the secrets and the certificates and so on. In Istio, at least, the certificates are kept in memory, so they're not stored onto disk anywhere. But nevertheless, you could take control of the proxy. And now the interesting thing about that is you can, the idea is those certificates get rotated after a period of time. So if something, if you are able to steal a certificate in some way, and try to exfiltrate it and use it for other things, then that first of all will expire, and then then you're in that situation. How do you deal with a compromised certificate? But by default, with, again, for example, Istio, and Istio is the one I'm going to use as my go-to reference, because I'm writing Istio in action.
Yeah,
and so that's the
awesome.
thing that I've had the most hands-on with right now.
You doing that for O'Reilly or
Manning?
Manning, okay, got it.
Yeah,
I'll look it up.
and we're making good progress. I mean, I started it 2 years ago. And
so that's like tremendous progress. Right, exactly. You're flying.
Hit some bumps. Went to a startup. Didn't have any time to write, and now we've gotten back to it. Got an awesome, amazing co-author, and we're shooting for published by spring.
Awesome. I see it. I will drop a link in chat for everybody so they.
I appreciate it. Yeah, thank you. And it's just in time too, because Istio's had a lot of changes in architecture and community and APIs and that kind of thing. So I think we're finally hitting a part where it's going to mature and it's going to start to stabilize a lot more and settle down, and that'll be the thing. But coming back to the security, like the certificates, if they get, you can, in Istio, the default workload certificate expiration is 24 hours.
Wow. Okay. So you get a new cert every day.
You get a new cert every day. You can change that. You can lower it. But if something gets compromised like that, then it will expire in a period of a day.
So here's a question that gets asked often and it's from one of the guests or people on the stream. We regularly get the question, how can we glue the creation of PKI certificates used for Mtls to an HSM and a central CA? So some kind of hardware encryption device and a central CA. Like, is that possible with Istio or Envoy in general?
So right now, Istio has its own built-in CA model. And what you end up doing is, from your HSM or your root CA, or the PKI that you have in your organization today, what you end up doing for Istio is you generate an intermediary signing certificate and you give that to Istio, and then Istio will mint certificates from that intermediate certificate. Now, there is work being done right now. I don't know if it'll be in for 1.8. So basically, in the Istio community, what happens is, someone you propose an idea or request for enhancement and so on, and then little by little the pieces get into the release. Right. So what's being proposed is to be able to plug in external CAs and have the workloads, basically send their certificate signing requests to an external CA and get it directly.
Nice.
And so being able to plug in with a bunch of existing CAs and that extensibility is work that is ongoing right now.
Great.
And we're going to start seeing some pieces of it in the next release, and then future releases from then on.
Yeah, that's great to hear. That's amazing. So yeah, that answers that question. Nail is right on the head. Let's see. As an app developer, I don't care if or how the cert was issued, just as long as it's got the right roles in the header and everything else. So yeah, exactly. Let's see. We've covered. So like, this appears to me to be the thing after Kubernetes, right? Like everybody asks me, or not
Yeah.
everybody, but like analysts or, VCs I'll talk to every once in a while. And they're like, so what do you think is after Kubernetes? Or just friends, like, what do you think is after Kubernetes, Chris? And I'm like, well, this is it. Service
Yeah.
meshes are it, clearly.
Yeah.
But I don't understand the why. Why is service meshes the next thing on top of Kubernetes that we're building? And maybe you can help elaborate on that.
I think there's two big reasons. The first reason is Kubernetes, and that kind of deployment platform is amazing at taking a container, which can run any kind of software or any kind of application, and doesn't matter what it's written in. Take that service, that application, and deploy it across multiple nodes in a large fleet, and make sure that there's a certain minimum number of replicas up. Start them, stop them when they need to, remove them around when they need to, check their health, make sure that they're healthy. Right. So Kubernetes is an amazing deployment platform and orchestration tool.
Yeah, it's a container orchestrator and a
Exactly.
platform for doing other things. Yes, absolutely.
Exactly. And so that's the number. Kubernetes is great at doing that. But then when you deploy these applications need to talk with each other. Exactly. They need to send messages. They need to authenticate and authorize each other. Right. You need to understand what's happening at the network layer between these applications. And so we need to solve that problem somehow. Right. So that's the first reason, because what's after Kubernetes? Well, Kubernetes lets you deploy your applications. What's after you deploy your applications?
Right.
You need
to talk with each other. Right?
Yeah. And then so the second reason is, just like Kubernetes solved the problem of deploying and managing software services and so on, regardless of what language they were written in, we have that same challenge of how do we solve the communication challenges,
right? How do we know
regardless of what language they're written in, because they are going to be written in all kinds of different languages and frameworks and whatever.
Yeah.
And so that's because you can solve. I gave you two reasons, right? The first reason was because you need to solve the communication challenges. You can do that in application code, but Kubernetes, like I said, allows you to deploy Java, Node.js, Python, Golang-based services,
everything.
And now you have to solve those problems in every single language, across every single framework, across every different version of those languages and frameworks, and keep it up to date, and hope and pray that it's consistently and exactly correctly rather implemented. And that becomes operationally very, very difficult and expensive and so on. So that's where the service mesh comes in to solve that problem in an application and framework agnostic way, similar to how Kubernetes and containers solve the deployment problems in an application and framework agnostic way. So that's the kind of the larger picture of why that is the next thing.
Right. Exactly. So someone just asked, what's after service meshes then? Is it serverless? Is it, well, maybe, but to be honest with you, I think this is my opinion. In general, like Kate serverless is an answer that everybody needed to like justify having all this hardware dedicated to all this application work, right? Like they need to be able to do serverless stuff on top of it. So Knative, et cetera, I think is a necessary tool. Like Kubeless, those things are necessary tools to, put in your Kubernetes clusters. I do think GitOps is kind of the next thing because it processifies, however you want to say that. It puts into practice good DevOps, skills and resources with a tool, and it's not that hard to actually kind of glue it all together to begin with. So that's my opinion. I'm sure, Christian, you have other opinions.
I mean, it's again, it goes back to the same question of what happens after you deploy your application. Oh, well, they need to talk with each other. All right. Well, now that they talk with each other, what do they need to do next? What's next, right? So now we'll probably look at ways of optimizing that, and maybe that's a serverless style, functions of service style mechanism. But the infrastructure and the things that you built to get there those are necessary pieces of functionality. Now, the GitOps and security and data and all of these things are all kind of, they're not necessarily layers per se, but they all kind of work together, right?
Right.
You need you
like
you,
it's
you want GitOps,
multiple
you want
things going at the
CI/CD.
same time, right? Yeah.
Right. Yeah. But I mean, you deploy your application and you find out whether or not it's successful, then you make money, right? So that's the next thing.
Right. Yeah. So like that's the thing, right? Like Kubernetes or serverless or service mesh, whatever it might be, is not necessarily destination. It is just a step along the way. It's complex. We get that. It's not exactly easy. There are tools now that have significantly eased the process since when I started using Kubernetes. So I'm happy for that. But there's much work to be done here.
I think one area that is particularly interesting and something that we're very interested in at Solo is, all right, you got your Kubernetes, you got your service mesh, but now you got to run them in big organization, right? All right, well, now we need this customization here. We need to extend the thing here. So in my mind, WebAssembly becomes the next big thing, I guess.
Yeah, well, I did state that last year at my end of year blog post. I think WebAssembly would be a bigger thing this year than COVID happened. But so talk to me about WebAssembly a little bit. What is it? Why would you use it? What's it for? Lay it out for the audience.
So WebAssembly originated in the web browsers and is in the web browsers right now. And its main purpose was to allow web application developers a way to write functionality that either, number one, needed to be executed faster than what the JavaScript engine can do, or number two, you had existing code or you didn't want to use JavaScript, but you still wanted to run it in the browser. And so with WebAssembly, you can take code written in your preferred language up to an extent, right? It's still evolving, and there's some constraints in WebAssembly. Take that, and then compile it down into a binary format, and then take that binary format and run it in a VM or a sandboxed environment, like a web browser.
Like a web browser,
And so if you take that same model and say, well, when I deploy my Glue Edge gateway, for example, and I deploy it at the edge, I want it to do OpenID Connect. I want it to do a couple of OAuth flows. I want it to grab some telemetry. But you know what? I'm, Citibank, and I have all of these non-standard security protocols that I need to somehow plug into the gateway because I need to support for backward compatibility or just compatibility with the rest of the organization. So now how do I do that? You can extend Envoy. Envoy is written, and like I said earlier, it's very extensible, but it's written in C++.
Right.
And if you modify it with C++, now you have a different distribution of Envoy that you have to maintain. And so that there's a lot of work that goes into that. Or you can do it out of process from Envoy, call Envoy, reach out to a different service, do your custom thing, and then return. But that's expensive, right? In terms of network and latency and so forth. So the idea is with WebAssembly, you can write this customization, package it up as a WebAssembly module, inject it dynamically into the data plane, Envoy in this case, do your custom code, custom whatever, and you're still running the same base Envoy. You haven't changed Envoy, so you don't have to maintain that fork. And so it's a way that allows you to extend the capabilities of your networking infrastructure at the L7 or application level, without having to stand up all these different services or take custom builds of Envoy and so on. So
it's a way to customize your proxy with a language that you're familiar with.
That's right. Yeah.
And just plug right into Envoy.
That's right.
So what can WASM do, or WebAssembly itself do, like in the browser, right? Like its capabilities are somewhat limited, I think, right? Like
I think computational computational use cases. I mean, that's where it excels. Even I would say in injecting into Envoy, it's a very strict boundary between WebAssembly and the host, right? So there's no shared memory. If you want to pass data into or out of the WebAssembly module, you have to copy it between the VM and the host. And if you want to call external services or external functions, those have to be made available to you very explicitly. And so there's limitations in that model. But for the browser, like I said, it was built in one respect to improve the efficiency of the applications that you're writing,
right?
For technically, high computational tasks. And in Envoy, it's about what you're doing in the network is manipulating headers and moving things back and forth.
Yeah.
Maybe looking at the body and of a request or something. And the model fits very well in Envoy. Now, the interesting thing is WebAssembly as a technology is useful in the browser. It's useful in Envoy, which is we're pretty excited about that.
Yeah.
But it's also useful outside of those. You can use them to extend. You can use WebAssembly, for example, to extend the control plane components.
Right.
You could use WebAssembly inside of Kubernetes, deploy WASM modules.
Yeah.
Maybe to extend Kubernetes itself. So this idea of WebAssembly as an extension mechanism is not limited to just certain hosts, like a browser or
right. So, when you build these binaries, there's a question in chat, like, are these binaries big? Like how, what are these binaries usually doing, I guess, is a good question.
They're not, I mean, everything that you want to run within the WebAssembly module has to be in there, right? So
it's probably a lot of like API translation type stuff, potentially, or, integrations with other services, maybe.
Well, so for example, a request comes in and I want to pull the JOT and do some evaluation of the JOT token, more than just making sure that it was signed correctly.
Right.
And so you pull it down, you do some calculations. If you want to reach out to another service, you don't actually write the code to do that. Envoy will give you a handful of functions that you could call that are managed by Envoy to be able to reach out, make HTTP call or whatever.
Cool.
So the actual computational code is pretty small, right?
Nice.
It's not like deploying. When I say VM, don't get that mixed up with like a JVM.
Yeah, with like a whole JVM kind of thing. Yeah, right. Yeah.
Yeah. So the VM is actually baked into Envoy. You just deploy the code, which is highly sandboxed. If you want to do call out to the network and that kind of stuff, then you use Envoy for that.
Nice.
So your code's actually pretty small.
Pretty isolated, pretty tight, pretty small. Usually a tiny little binary that's actually getting run there on the edge.
That's right. But now the next question is, all right, how do I get started with that? How do I How do I
get started with
a WebAssembly project? And then if I do, how do I put it into Envoy or into a service mesh or Glue or something? And at Solo, we've been looking at that problem since at least December last year.
Right.
We announced something called Webassembly Hub.
Okay.
Cool. We announced recently a sort of OCI compatible spec that describes what a WebAssembly module looks like.
Nice.
And can then be shared in different registries and so on.
That's cool.
Yeah.
I appreciate OCI specs.
Yeah.
I really do. I will share Assembly Hub right now with folks in chat so they can check it out for sure. But having an OCI compatible spec makes it so that basically anyone can make use of this hub and search it, and it's just like another repository of any type where you would get containers from or whatever. So that's very cool. Thank you for doing that. That's nifty as all get out. The cool things, like, what are some of the most popular things in WebAssembly Hub, I guess, is what are you seeing as stepping
we just wrote a blog called The State of WebAssembly in Envoy Proxy.
Okay.
And I can share that with you. I think it'd be useful to share with people who are looking at this, because WebAssembly is not production ready. or at least WebAssembly in Envoy is not production ready. And in this blog, we tried to outline, well, what are the pieces involved?
Right.
What level of maturity are each of these pieces, and what to expect if you want to start kicking the tires today? Because this is the go forward, solution for customizing your data plane in a networking environment, but it's not there yet. And so in that blog, we talked about, the Envoy filter, the Envoy interfaces between the WebAssembly and Envoy, the state of those, the state of the SDKs that you might use to build these WebAssembly modules, and then what to expect from a POC. And so I'm answering your question by saying, well, there are things like evaluating the JOT. There are things like evaluating headers, adding headers, removing them. Yeah. I think there are a couple where they're looking at the body and maybe doing some light transformation and so on. But the capabilities will expand to the extent that the APIs solidify and expand in terms of what they enable you to do, but then also solidify and stabilize so that people can actually start using them and building on top of them, things like SDKs and so on. So that is still in flight, but it is seeing a lot of forward progress. So I don't expect it would be too much longer that we see WebAssembly land in upstream Envoy, first of all. And then from there, the ABIs, the binary interfaces between Envoy and WebAssembly, start to stabilize and solidify. And then, SDKs, a lot of, the SDKs start to build and we start seeing more modules, WebAssembly modules.
So, okay. So there's a question in chat and it helped me eliminate some confusion here, right? Like there's JS, there's CSS, and then there's WASM, right? Like WebAssembly is something that sits on the proxy side, or it could essentially, be part of the website itself or be delivered as, a binary that runs inside the browser.
So WebAssembly in the browsers is something that gets delivered along with the JS, CSS, and HTML.
Right.
WebAssembly in Envoy proxy. So Envoy proxy, we're not talking about JS and CSS and that kind of stuff. We're talking about giving Envoy configs to make it behave a certain way, and this WebAssembly module, which changes some of the capabilities or enhances some of the capabilities that Envoy has, right? So it is in a browser. That's something that actually gets delivered to the browser. Browser executes it. In Envoy, it's something that gets delivered to Envoy. Envoy executes it and expands its capabilities, customizes its capabilities.
Awesome. Okay. Thank you for clearing that up.
Yeah.
So Brian Tanis, who is a coworker of mine, he's on the Dev Advocate team now. He's been here for a while. He's trying to get into the Envoy community. What is kind of like the road to get involved and get started with, contributing upstream to Envoy and then helping out with things like you're doing?
Yeah. I would say Envoy is a fairly complicated piece of technology to operate and to use. I would say things like contributing how-to guides or videos about there's so many hidden, I feel like, capabilities of Envoy proxy. Unless you're the one that helped drive that feature,
right?
It's sort of, or you're scouring the docs. There's a lot of capabilities that get overlooked. One of my favorite ones that gets overlooked is Envoy has the ability to do locality-aware load balancing, but also something called request racing or request hedging, which allows you to send a request to a service. And if that service doesn't respond in a given certain amount of time, right, it times out, Envoy can resend the request and it won't give up on that first send, right? So even though it timed out and it issued a retry, it's still going to wait. So whichever request comes back first, so if maybe it's the retried request, or maybe it was the original one, Envoy will send that back. And that's so cool. That's like one example of many that the resilience in networking resilience capabilities of Envoy that are baked in there. So there's a lot of those.
Yeah, there's that, like my head just exploded with all the capabilities that you could do, like interconnectivity with like, oh, I need to call these 7 APIs, or I need to pull these 8 files or whatever, right? Like try another endpoint, try another endpoint, try another endpoint, right? Like that's amazing.
Yeah.
Wow, you could build a ton of resiliency right there into your edge layer, no problem.
That's right. That's right. And so my suggestion is, and this is what I do, is I go in there, help understand some of these capabilities, help explain that to people, write blogs, videos, whatever, and then slowly start to understand. All right, what does the configuration look like for Envoy? What is the configuration model and the API that gets used for that? How is it implemented? And so then you can start to dig a little bit deeper into, this is C++ code, and how is it structured inside of the code, and start to answer questions and issues on the public chat, either on Slack or the Google group or whatever.
Yeah. So
there you go. That's the approach that I take. I would recommend that to other folks as well.
That's awesome.
Yeah.
So yeah, what is Glue is new. Glue's a startup. Glue just got its Series B.
So Solo's
sorry, I always get the product in this. It's because they're 4-letter words. I forget.
We have a very strong branding around our products. Yeah.
So Glue is what exactly?
Yeah. So at Solo, like I said, we're core competency is Envoy. We believe Envoy is the foundational piece to this next generation application networking that manifests in 2 big ways. One is service mesh, which we talked about today, and one is the edge. How do we get traffic into our clusters, into our mesh? And interestingly, across multiple different clusters or deployments or clouds or on-prem or cloud, right? You need some edge security, rate limiting, cluster transformation, these types of things.
Yeah.
But that also ties in and plays very harmoniously with the service mesh. Right. So at Solo, we built Glue, which is our gateway, edge gateway, solving some of the edge problems, request transformation, rate limiting, OIDC, OPA, Open Policy Agent integration, all of these things that you might want to do at the edge.
Right.
And then ties in very seamlessly and natively with a service mesh, so you can get traffic into your mesh. And then for service mesh, we have an enterprise distribution of Istio, for example, and we support Istio. But the more interesting challenge, and this is why I said we're focused on the challenges that enterprises have when they adopt technology like this, is how do they operate it? And so there's a lot of nuance to that. How do they operate it across multiple different groups in their enterprise? Right. These enterprises need different APIs. The stock Istio API is not suitable for, I would argue, anyone, but for different groups, right? You don't use that API directly.
Yeah.
So something like, our product Service Mesh Hub focuses on, what are the right persona-driven APIs in a different organization? How do you operate this thing across multiple clusters? Because that's not simple. How do you do service discovery, identity federation, service failover, all this kind of stuff?
Yeah.
And then the last part is the really hard stuff. The last part is, we know people are going to go from on-prem to a public cloud. Yeah. We know that they might start in a public cloud and might want to use a different public cloud at some point, right?
Sure.
So we know that at the application layer, at the networking layer, it really shouldn't matter whether you're using Istio or App Mesh or both, right? So we've built our technology to be able to accommodate those use cases, and so that's a very, and then of course the WebAssembly stuff sprinkled in between, right? How do you extend the capabilities of these different pieces of infrastructure? So that's what we're focused on at Solo.
Cool. So I'm looking for questions. Hang on. Sorry, I got distracted by an email real quick. Working with content enablement is awesome. Good suggestion. Thank you. This is from Brian. What would you suggest? Where would the main places be to get the word out to people who are using Envoy? Is there like a Slack, a Google group? I'll send you a note to not derail the conversation. Thanks again. But yeah, like where do Envoy people hang out? I know there's an Envoy Slack. I
Oh yeah, there's
know.
Envoy Slack. I would say Istio. I would say any of the service meshes. So AWS App Mesh has a Slack.
Mhm.
Um, Istio obviously has theirs. Console Connect also uses Envoy. Microsoft Azure announced Open Service Mesh. They use Envoy.
Yeah.
And there's a couple others. So definitely those are areas of interest for Envoy. I would say things like API gateways, like ours, Glue's open source project.
Right.
You can look at Contour. Oh, I missed Kuma.
Oh
Kuma
yeah.
is a service mesh built on
Yeah.
Envoy.
Yeah. I forgot about that.
Yeah,
There's so many of them.
I know, right? It's hard to keep track of them now.
Yeah.
Yeah, those areas definitely. But in general, I would say anybody who's interested in Kubernetes should be also interested in how their applications talk with each other.
I would agree with that.
And so those communities are good areas as well.
Awesome. All right. I think that answers all the questions. Is there anything else you want to tell the audience where to find you? All that kind of fun stuff.
Yeah, I'm on Twitter at Christian Posta, first name and last name. Emails christian@solo.io. I try to share as much as I can, time permitting, with my writing. So blog.christianposta.com. I try to share about patterns, share about experiences that I'm seeing in the field. So I work very closely with customers at Solo, and I try to bridge the marketing BS stuff, which is necessary, with the on the ground. This is what's really happening at large enterprises or anybody trying to adopt this technology.
So are you that guy in Office Space that takes the stuff from engineering or from the managers and gives it to engineering, right? Like, I'm a people person, damn it.
Yeah. Exactly.
But no, your content is fantastic. And like, I devour it, right? Like, so thank you for putting it out there. It really sheds a light and opens my eyes to the world of service meshes and Envoy and proxy and what's going on in that whole landscape. It's amazing to me. Like WebAssembly is quite possibly a game changer for a lot of different things. So I'm trying to keep my pulse on it the best I can. There are newsletters out there about it. There's newsletters about Envoy. There's newsletters about Istio. There's newsletters about Solo and Glue, I bet. So yeah, subscribe, get all the information you can. Definitely check out Christian's blog. Follow him on Twitter for sure. And thank you again, everybody, for joining. Thank you, Christian, for joining. And, check out Solo or solo.io. I can say that right. Check out solo.io, see what they got going on. And we'll look forward to seeing you tomorrow for an OpenShift Commons briefing. And when in doubt, check out the calendar to see what's up next and like and subscribe wherever you're watching us from. Thank you very much, Christian, and everyone else. We'll see you soon.
Thank you, Chris. Thank you, OpenShift TV.
Quite welcome. Thank you.